is Math 139, Section 1.4. And in Part A, we're going to be looking at simplifying quadratic expressions or quadratic functions by expanding them. So when we look at a quadratic function, there are actually two ways that we might frequently see it. Sometimes we see it all multiplied out like this. We often call it expanded form or even standard form. And sometimes we see it factored as a multiplication problem, the factored form of the quadratic function. Right now, we're going to be assuming that we start with the factored form and we'll multiply it out to get to the expanded form. In our first example, we can see that the factored form is 2x plus 5 multiplied by x minus 3. So we'll go ahead and do this essentially as two distributive laws. First of all, we'll distribute the 2x to both terms in the second polynomial, giving us 2x squared minus 6x. And then we'll distribute the 5 to the same two terms, giving us a plus 5x and a minus 15. It's common for people to have learned this multiplication process where we're taking a binomial times another binomial. And remember it using the acronym FOIL, F-O-I-L, which stands for first, outer, inner, and last. First means you multiply the first terms of each binomial. 2x times x gave us the 2x squared. O stands for outer, the outermost terms of the binomials. 2x times negative 3 is negative 6x. I for inner, the innermost terms of the binomials, 5 times x. And finally the L for last, the last term of each binomial, giving us negative 15 here. Whether you think of this as two distributive laws, or if you kind of remember the acronym FOIL, you'll come up with the same thing. All right, so let's just simplify here. We have our 2x squared. The middle two terms are like terms, so I'll combine them to a negative 1x, or just minus x, minus 15. And there is my expanded form. All right, number 2, another example of being given the factored form, or at least the partially factored form in this case, and wanting the expanded form. Notice here the x plus 7 is just kind of on its own. It's not multiplying anything. It's just this negative 3x that I have to multiply or distribute into the parentheses. So for right now, I won't change the x plus 7. When I distribute the negative 3x, I get negative 3x squared plus 6x. I always like to write my answer in descending order, so I'll start with the negative 3x squared. And then I'll combine those terms. 6x plus 1x would give me a plus 7x. And finally the constant term, plus 7 at the end. All right, one more. And this one I want you to be especially careful with because there's very common mistakes that occur with this problem. The problem is to take 3x minus 5 and square it. When you square something, it really means to multiply it by itself. So in this case, that would mean taking 3x minus 5 and multiplying by itself, another 3x minus 5. When you look at it in that form, it's clear that we have to use that FOIL process, or double distributive law. I would get 9x squared negative 15x, another negative 15x, and then a positive 25. That gives me 9x squared. Combining negative 15 and negative 15 gives me negative 30x plus 25. Okay. What I'd like you to specifically notice here is what doesn't work. A lot of people try to do this problem by just saying, oh, let's square the 3x. Well, that would give us the 9x squared. And let's square the negative 5. That would give us the positive 25. But notice, if you don't write this out, if you just try and square the two terms separately, you're going to miss that middle term every time. So it's always best when you're squaring a binomial, write it out. The binomial times itself. That way you won't make that very common error. This is the end of Part A.